What is common between wet clothes drying on a hanging railing, blow drying your hair, ironing your clothes, and sweating during exercise? In all cases, the liquid transforms to gas below boiling point. This particular process of change of state at below definite temperature is known as evaporation. In this session, we will talk in detail about this process and impact of physical conditions at the rate of this process. Evaporation is the process through which liquid transforms into a gas at any temperature. This happens because liquid molecules absorb energy from its surrounding and become energetic. These energetic molecules rise to the surface from where they escape to the surrounding. As energetic molecules leave the liquid from the surface, this leaves behind less energetic molecules in the liquid. As they possess less energy than before, the remaining liquid is at a lower temperature than before. An important point to note is the cooling effect of evaporation. Liquid molecules absorb energy from surroundings or the object in order to escape. As they absorb energy to become energetic, the object or surroundings lose energy. This loss of energy lowers the temperature of the object or surrounding. Moreover, it is the loss of energy due to which evaporation has a cooling effect. It is the reason why you feel cold when you jump out of the swimming pool or shower. The water on your skin absorbs the heat energy from the skin to evaporate. The skin in turn loses energy, which lowers its temperature. The high loss of heat energy causes our body to shiver and feel cold. Rate of evaporation depends upon the temperature of the liquid. We know that in evaporation, molecules absorb energy in order to become energetic and escape from the surface of the liquid. Below, we have a wet cloth hanging over the railing to dry. The sun is shining brightly over the cloth, transmitting energy to it. The energy is in the form of light, a photon. Molecule absorbs this photon to become energetic and escape. At higher temperature, there are more photons reaching the molecules, causing a greater number of them to escape or evaporate. Similarly, at sunny days, the rate of evaporation will be high when compared to the cloudy days. During sunny days, more heat energy reaches the surface compared to cloudy days. As more energy reaches the surface, the rate of evaporation will be higher compared to cloudy days. So at higher temperature, the rate of evaporation is higher. Rate of evaporation depends upon the surface area of the liquid. We know that in evaporation, molecules absorb energy to become energetic and escape from the liquid. Below, we have a wet cloth hanging over the railing to dry. The sun is shining brightly over the cloth, transmitting energy to it. This energy is in the form of light, a photon. Molecule absorb this photon to become energetic and escape. At greater surface area, more energy reaches the surface of the liquid, causing greater number of molecules to become energetic and escape over a greater area. Below, we have liquid evaporating from both a river and a puddle. Even though same sun is shining over the liquid surface, the rate of evaporation will be higher in the river. This is because more molecules absorb heat energy and have a greater area to escape when compared to liquid molecules in the small puddle. We can reduce the surface area by covering the surface with a lid. So, at higher surface area, the rate of evaporation is higher. Rate of evaporation depends upon the wind conditions over the surface of the liquid. We know that in evaporation, molecules absorb energy in order to become energetic and escape from the surface of the liquid. Below, we have a wet cloth hanging over the railing to dry in cloudy conditions. The gentle breeze blows and sways the wet cloth, transmitting kinetic energy. At a microscopic level, the wind blows over the liquid molecules that are tied with the fabric of the cloth. As the wind blows, it transmits kinetic energy to these molecules, causing them to become energetic. These energetic molecules escape, resulting in evaporation. At higher windy conditions, temperature is generally more cold. Stronger winds blow over the cloth, giving greater kinetic energy to molecules. As kinetic energy given is higher, greater number of molecules escape, improving the rate of evaporation. So rate of evaporation is directly proportional to the wind speed. Wind carries away the molecules on the liquid surface. As wind speed increases, the rate of escape of molecules also increases, causing greater evaporation. We are now going to compare both boiling and evaporation side by side. In both processes, the liquid molecules transform into a gaseous state, but there are key distinctions. Firstly, in boiling, the heat energy is provided by the source, while in evaporation, the heat energy is absorbed from surroundings. Secondly, in boiling, all liquid molecules have enough energy to transform into gaseous states. Bubbles form throughout the liquid, while in evaporation, the transformation mainly occurs at the surface of the liquid. Thirdly, as heat energy is provided instead of absorbed, boiling is a quick process. However, evaporation is a slower process because heat is absorbed from the surroundings. The output is the same in both processes, vaporization. However, the processes themselves vary in a number of ways which you should be aware about.